Dear viewers, welcome back to our series covering our vision on end-to-end development of autonomous driving functionality. In this session, we will show how to set up a containerized software development environment for our project to ensure fast onboarding for our project members and all developers use the same environment to create and build software. The audience we are addressing with this series are technical people, but also managers working in the area of autonomous driving or in more general people who are part of the transformation of the automotive industry towards the software-defined vehicle. It's important to note that the principles and approaches discussed in this session are applicable to any form of software development, not just autonomous driving. Thank you for joining us. Today, we will explore the challenges faced by developers in traditional workplace setups and how our approach overcomes these obstacles, leading to a more efficient and productive environment. First, we'll delve into the traditional developer workplace and the various challenges developers encounter. Then, we present a developer workplace powered by Container as a game-changing solution. Next, we'll illustrate the developer environment management model, demonstrating how and when the container can be updated and utilized. And at the end, a demo of a containerized development environment will be presented to showcase how easy it is to start and the features it can provide. We aim to motivate you by highlighting the benefits you will gain from adopting the proposed solution. By the end of this video, I hope you will better understand the advantages and importance of having an easy-to-set-up automotive development environment. Become familiar with the streamlined onboarding process. Gain more insight into how this solution can increase developer productivity. Realize the potential for cost and resource efficiency through the implementation of this solution. Recognize the cross-platform compatibility of the proposed development environment. Understand the significance of standardization and consistency in the development process, leading to improved outcomes. Before we jump into the topic, let's look at the areas of the underground map that I am covering today. If you are not familiar with this map, you'll find a more detailed explanation in the introduction session I will link below. In today's session, we will cover setting up the C++ development environment and show how to use it to build and debug C++ code. We will also show how to include predefined project configurations to make sure all developers follow the same standards. Let's dive into the topic of enhancing the development environment for C++ developers. In a traditional C++ developer workspace, each developer or IT department typically installs the development environment directly on their own PC. First, they need to install the necessary tools, libraries, and SDKs, making sure to use the correct versions. Once everything is set up, they can then proceed to pull the repository and build the project. However, it's important to note that every developer is required to go through this installation process individually. This approach often leads to a repetitive and time-consuming setup process for every developer joining the project. In an advanced driver assistance system project, a large team typically collaborates, including developers and testers. Their collaboration is crucial for the project's success. Before starting a project, new developers need to familiarize themselves with the necessary tools. However, this process can be complex and time-consuming, particularly when it involves installing the required tools. Managing licenses is another challenge, especially considering the rising costs of licenses nowadays. It's important to keep up with new versions and ensure that shared licenses are properly provided. Setting up the development environment is essential for each developer. When there are many developers involved, minimizing the setup time becomes crucial. Moreover, if a developer switches projects or works on multiple projects simultaneously, installing or removing specific software versions can lead to compatibility issues and code failures. Over time, development environments tend to differ due to varying extensions and updates. This can cause confusion if the project's wiki contains outdated or incomplete information. Having different developer environments also makes it difficult to pinpoint the root cause of errors. Reproducing errors for debugging purposes becomes increasingly challenging. Considering all of these factors, it becomes clear that a shared developer environment is necessary. To have the same, but still separated environment, we have used container images. A container image is a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. Containers share the machine's operating system kernel and therefore do not require an operating system per application. The base container image is shared between CI/CD pipeline and the developer container. Developers have their own local computers, usually with the OS and IDE installed by IT. To work on the project, developers then need to pull the developer container image from the container registry and start the container, in which the IDE extensions and setting is already set up. The building, testing and other tools, like a debugger, are ready to be used. The source code is usually in a code registry, using Git versioning in DevOps. Developers can pull the source code, mount the folder to the container and build, test, debug, and so on. With this setup, we can reduce the time of the setup and at the same time ensure consistency of the development environment used across the whole project. To manage the development environment for the project, we do not need the IT department, as we can update the tools and SDK inside the container. If a developer updates the container inside the container registry, other developers can be notified and they can pull it from the container registry. Let's see it in practice in a live demo. Let's assume that you are a newcomer in the team and that you need to start working on a project, building the code and start developing. So, you get your PC with OS and IDE installed from the IT department. In the demo, we have Windows as the operating system and Visual Studio Code as an IDE. What else do you need to start your work? You need access to the container registry and the code registry. As you can see here, I have already created an SSH key pair to be able to clone the repositories. Now let's clone a repository. I usually make a workspace, for example a repositories folder, and then clone the repository inside it. Let's go to this folder. Now I try to build this project in my Windows virtual machine called WSL2. Let's call Conan install. Here you can see that I didn't install Conan on my WSL2 and therefore I cannot build the project. Until now, I have cloned the source code inside the local virtual machine. Now I want to pull container content from the container registry. I use login. And then pull. With pull, we see that our latest version of the developer container image is 010. So I pulled 010 and now I can start it. Now I can run the container. The parameter itd here say that it should always run in the background interactively. Shares the host's network namespace with the container, assigns the name odd-a2e developer to the container, sets the display environment, mounts the host's repositories directory into the containers, grants the container extended privilege, which should be used with caution. And this is the name of the container image. Now I can attach to the container. And here I'm inside the container as a root user. I can go to the repository application ACC vehicle state estimator. From here, I know that it has already CEMake, Clang, and Conan installed in the container image. Let's see if I can build this project now. Add Conan remote and user. I try Conan install again and I can see that it downloads all the dependencies. Now I can build it. So, as you can see, it was a very fast start for a new developer to build the repository. We showed that we have pulled the container from the container registry, and the container already had Conan, CEMake, and Clang installed, all the tools that we need to build the source code successfully. Until now I explained this part of the image. We have cloned the source code. We pulled the container image from the container registry. And we were able to build the executable inside container. Now I want to connect my IDE to the container, which is already running in the WSL as a virtual machine. In our case, our IDE is Visual Studio Code, running on Windows. It offers lots of extensions. I have installed the WSL extension and the dev container extension. With the WSL extension, I can easily connect to my running WSL. And we also know that our container is already running inside the WSL. So now, with the dev content extension, I can attach to this end-to-end development container. As it happened, it also installed some extensions that I've already set up in container. For example, Clang format is already added as an extension and it is also set up inside of the container. Here are the extension settings. We can see that it's using the Clang format. It is already installed inside the container. Here's where we're saying which file to use. In this example, it uses the Clang format file from our project. This is the Clang format file path. Format on save is also already set up in container. So if I open a source code file, change something, accidentally mess up the formatting and then press save, the formatting will be corrected automatically. Another example is the debugger extension, which is by default installed inside Visual Studio Code. We have also added the GDB debugger extension, which is CPP tools. And GDB version 10 is also installed in the container. I can add the configurations here. You can go to Add Configuration and add the launch GDB. And I have already added this executable file to debug, so I can show you that. Add the GDB launch file here. And then just add the path of our executable here. Now, let's run it. You can see that it runs the file. I can add also some breakpoints here. And then it stops on the breakpoint line. You can see the local variables, in our case. dt, your rate, velocity, and acceleration. You can also add other variables you want to watch. There are some registers that are also visible. So, we can go through this breakpoint and as you can see, we have now set the velocity equal to this variable. In summary, we have shown that the IDE is connected to the container. We have already installed extensions of the IDE inside the container. The tools and the library that helps developers to debug is also installed beforehand in the container and ready for the developers to use. To summarize, what we have demonstrated today is as follows. Setting up the automotive development environment with containers allows for a quick and efficient process that can be completed in minutes. This facilitates a smooth onboarding experience for new employees, as they only need to set up the environment once, and subsequent setups can be done with a few mouse clicks. The container provides helpful features such as auto-completion and hints from the compiler, which aid developers in focusing on algorithm development while adhering to coding standards. Another advantage of this approach is its compatibility with any operating system. Developers can follow the same steps of CI/CD pipeline, format code, and run unit tests. By utilizing containers, the software version in our pipeline remains consistent throughout. At Luxoft, our mission is to empower your organization with cutting-edge solutions that cater to your unique needs and objectives. We collaborate with your teams to understand the specific needs and challenges and provide solutions. We support maintaining and continuously improving your existing software factory landscape you use already today to deliver your automotive software assets. In case you don't have one or plan to completely redesign and set up a new environment, we are happy to support here and provide a solution. Luxoft is vendor agnostic in terms of tools. We work together with all tool providers and also leverage open source tools to build the best solution for the client needs. Obviously, We also can support developing your software assets with experienced automotive software development teams, extending your existing team or taking over full responsibility of work packages or fully maintaining your assets to free up your internal personnel to work on new features. I hope this video was helpful to provide a clear understanding of the benefits and potential of adopting a containerized development environment. If you liked this video, please press the like button. We are very interested in your opinion. Please feel free to provide your feedback in the comments section below. In case you need our support, please contact us using the contact form on our homepage. In the upcoming videos of this series, I will focus on model-based systems engineering process and explain how to leverage it to build reusable and maintainable software assets for the software-defined vehicle and demonstrate how fuzz testing can help to make your software more resilient to cyber attacks. And speaking of software assets, I am not only talking about source code and binaries. Especially for automated driving features, we need to consider also the system requirements, system architecture, and the related functional safety artifacts that are part of this asset. If you want to get notified when we submit the next sessions of this series, please subscribe. Thanks for watching. Looking forward to meeting you in the upcoming videos.